All right, good afternoon. Thank you all for coming out. My name is Cedric Owens, and I'll be talking about some ways around some common macOS detections using the Swift programming language. So some background information on myself. I'm currently on the Red Team at Box based out of Austin, Texas. Prior to doing Red Team, I come from a largely Blue Team background, doing incident response, threat hunting, threat detection. And so that's still a part of me that's really near and dear to my heart. I really like working with Blue Teams, helping validate detections, helping Blue Teams understand the attacker's mentality, for different approaches, and just integrating with Blue Team in general. I really enjoy that. Also, I know Red Team is very broad and encompasses many different things, but for me personally, post-exploitation is an area of interest of mine. Like, I enjoy the cat and mouse game of evading or trying to evade the latest preventions and defenses. Also, I was an early 80s baby, so I do enjoy things that remind me of the 80s. So you'll see some memes throughout my presentation reflecting that. And Twitter handle @CedOwens, where I'll occasionally post some things there. So what I plan to talk about is I plan to start off talking about the state of the union through my eyes for macOS from an offensive and defensive perspective, common post-exploitation methods that we've seen for macOS up to this point, and the associated detection artifacts. And then why migrate to macOS internals for post-exploitation? Like what benefit will we get from that? How can we do it? And then last, talk about some examples of doing just that using the Swift programming language. So, state of the union, I would say again through my eyes, the latest desktop operating system market share numbers I've seen, Windows was around 77% and Mac was around 14%. So still a huge gap where Windows is leading the way, which is why most of the tactics that we read about and see are Windows focused. However, if you look in your Fortune 500 companies, a lot of household names that are Windows shops and probably will be Windows shops, one thing that I am noticing is that VIP users such as executives or admins with a lot of rights are being segmented over and more often over onto Macs. So you look at that and you look over and look at tech companies in the Bay Area, and it's almost a complete opposite, where the vast majority of endpoints are Mac OS with very little Windows. So I think from an offensive and defensive perspective, it's hugely beneficial to be familiar with Mac OS. Just because even in a Windows shop is going to be likely at some point you're going to have to either target a macOS device or investigate it, dig into it. So I think that would be useful. In terms of endpoint detection and response products, those have definitely come a long way. The first time I remember getting exposed to EDR from Mac, it was really basically a flat file logging system. The logs were barely normalized. There wasn't much intelligence out of the box that would be useful to a Blue Team. And so you fast forward a few years now and EDR has gotten better. The logs provide the analysts with most of the stuff that are needed in most EDR products. And there's even some decent out of the box detections. In terms of post-exploitation, what I've seen mostly up to this point have been scripting-based post-exploitation, where the post-exploitation tool itself lives on the command line. And when I say that, basically using a scripting language, such as Python as an example, to access shell commands that the tool uses for post-exploitation. So speaking generically here, when it comes to detections, most detections have existed in this blue box here, focused on command line and processes being spawned. And the reason being is because most of the post-exploitation tools up to this point have also lived in that blue box. Again, living on the command line through some type of scripting language on the host. So you've got your command line where processes are spawned, which you do various things. And at the end of the day, the process is really just a front end for a back end API call. And so kind of what's happened in the Windows side of the world is kind of what I've been pushing myself to do, is like get off the command line completely, limit the number of processes I create, and bring my own code to invoke API calls directly. So I'm not completely bashing scripting languages at all. Like Python is my favorite by far. And I even wrote my own post-exploitation tool for macOS in Python. But I wrote it from a bit of a different reason. It's called Max Shell. And I wrote it, for one, I wanted to go myself. I wanted to get underneath the hood of post-exploitation so I can understand what are the unique challenges with writing your own. What considerations do you need to keep in mind when building your own? But I also wrote it for blue teams, where it's very simple. It's just a client and server script. So blue teams can easily follow along the logic for how post-exploitation works, how the communication between client server happens, how an operator controls an endpoint, things of that nature. And so as I wrote it, a couple things stood out to me. I kind of assumed that, with it being 2018, 2019, around when I was writing it, that a lot of the approaches used by this would be detected by most EDR products. But I was pretty surprised to find that was not the case. A lot of the post-exploitation using Python, running command line utilities were still not detected. So I put my blue team hat on, worked with blue team, started analyzing it, and started to find a lot of common patterns that blue teams could easily key in on. So some of those patterns include parent-child relationships. So speaking of Python in this example, for post-exploitation, OS libraries like system, popen, commands for Python 2, subprocess for Python 3, they all operate in a similar way when you look at parent-child relationships, where by default you have Python spawning a shell environment, which in this case by default is binsh. You could totally change that. But Python spawning shell environment, which then executes the command. Another thing that blue teams could easily key in on that I saw as I was analyzing my own tool was a count of network connections from Python. Since in this case, Python is running and makes that initial connection to the server, on the client side, the host you're controlling, Python is just really sitting there waiting for the next command from the server. So you could build some analytics around that and see how Python's beaconing out. Also, command line strings. Again, since tools up to this point have lived on a command line, these are things blue teams could easily key in on. So screen capture, -X, that's the native way through the terminal on macOS to get a screenshot. -X tells it to do it quietly without making that camera click sound. Or OSA script. And OSA script is really an engine that allows you to run AppleScript on macOS, which allows for easy automation of simple and complex tasks. So like OSA script with the word pop-up may indicate that there's a user who's getting prompted to enter credentials or click a button or do something. OSA script in clipboard, that may indicate that the user's clipboard contents are being accessed. So those are some common things and examples of traces that blue teams could easily key in on when your post-exploitation lives on the command line. And so here's an example from my tool Max Shell. One of the operator commands I had was check security. So when the operator enters check security, that command gets sent over to the client that you're controlling. And what happens on the client side is it evaluates that command and converts it to a PS command, where it starts grepping for things like EDR products or antivirus, and then it sends the results back. So the operator knows what AV or EDR products are running. From an EDR perspective, this fits nicely into what was shown on the previous slide, where you have Python spawning binsh, which in this case spawns PS to run this command. And so if you step back over time and look at a post-exploitation running, you continue to see the same thing over and over. As Python waits for commands from the server, each time it gets a command from the server, a new binsh instance is spawned, which allows the system to in turn operate or execute whatever shell command that the operator is trying to run. So this is typically how, over time, it looks when your post-exploitation lives on the command line. So some pros for scripting-based post-exploitation living on the command line, it's been convenient up to this point. Scripting languages have been on macOS natively, so it's not like you have to install anything. There's less headaches. Like you don't have to worry about Gatekeeper. You don't have to worry about digital signatures, notarization, sandboxing, things that will cause an attacker more time and planning. And it may still go undetected in in a lot of environments today that may just not be focusing on macOS. The cons, however, there are teams that are blue teams that are used to defending macOS enterprises at that level, and they're familiar with these tactics. And if they see something running on the command line and they have alerting for it, it will burn down a red team operation really quick and early in the process. And it also provides very limited options for macOS. Like there's lots of other things you can do for post-exploitation on macOS beyond just the command line. And so this was something that also really stood out to me looking at developer notes and how, like I said, up to this point, we being offensive engineers have been able to take advantage of the fact that scripting languages have been on macOS. But going forward, the plans are to remove those going forward. So we'll no longer be able to make that assumption if we're doing a red team operation and planning, we're targeting Mac, that we can use Python because it's going to be there. Yeah, a user can install it themselves, but it's just not a guarantee that the target user base will have it on. So for me, this was a reminder that it's time to start pivoting and trying some different techniques. And so that's what brought me to the next aspect of thinking what's gone on in the Windows world, where you think about batch commands that eventually evolved to PowerShell, which eventually evolved to C#. And over time, just getting away from the command line and starting to invoke API calls, like can we do the same thing for macOS, which will basically allow us to challenge the way we've been doing detections so far. So what I did is I challenged myself. I showed you guys the slide earlier for Mac Shell, which is the client piece that's running the host you're controlling is in Python. So I challenged myself as a side project to rewrite that over into Swift so that I can then take as many command line based post-exploitation tasks and convert them from the command line over to API calls. So I picked Swift as the language. Objective-C would have been the other option. Objective-C has been around for a while. Swift is pretty new, but I personally like the way Swift is laid out, so I picked Swift. And it gives the same access that Objective-C provides in terms of a lot of the API calls that I would need for post-exploitation, like such as the Cocoa API, which you could do things like anything from screenshots to navigating the file system, and OSA Kit, which you can use to programmatically run JavaScript for automation on your macOS endpoints. But long story short, I picked Swift and started down that road, and it gave me that ability to meet that goal of moving off the command line. So quick steps that I took when setting up, getting started down this road is I downloaded Xcode from the App Store for macOS. It installed the corresponding version of Swift based on whatever version of Xcode you download. I used Playgrounds initially just to get familiar with an idea or a concept or syntax. Once I got comfortable, I then migrated over to projects like an app package or a Mako binary, built the code and then compiled it and executed it so I have my binary. So once you're inside of Xcode, this is kind of what it looks like when you start a new project. So as you can see here, there's tons of different options of what you can build through Swift or Objective-C. For this talk, I'm focusing on the areas of command line tool option at the top, which I've used to build standalone Mako binaries, or the Cocoa app, which I've used to build app packages for Red Team use as well. But there's tons of other options, and they all allow access where you can use the same powerful API calls. So I mentioned earlier that I challenged myself to convert the Python client over into Swift and get off the command line. So next I'll just show you guys some examples of what the command line argument was and what the code equivalent is when you invoke the API. So first example, my tool MacShell ran the screen capture command and spit out a JPEG of the screenshot. So what that looks like from a code perspective is using the Cocoa API. I also imported a third-party package called Socket so that I could make a socket connection and send the screenshot. But essentially what's happening in the code here is you're enumerating your active displays, you're getting image content for each, and you're storing that in a variable so that then you can like write the screenshot to a file, send it to a server, kind of whatever you want to do with that at that point. Second example, faking, I guess prompting users with fake authentication prompts using OSA script. You feed it on the command line, you feed it these AppleScript parameters to say, hey, set this dialog with this message, have a text box, so forth, and so on. So what it looks like in code is, again, with the Cocoa API, is you can build an NSAlert object from the NSAlert class, and then you can manually build the items for that alert that you want the user to see. So you can build your window title, your text, you can add buttons this way, you can add a text box, and then what happens is you capture the user's interaction with that alert. So you capture what text they enter in the box, you capture what buttons they enter, things of that nature. So this is a way to do that same task that's on the command line before programmatically now, which makes detection a little bit harder. Another example is you can invoke the NSAppleScript class and just feed the AppleScript command to that class. So in this example, you're actually still using the AppleScript engine. The previous one I just showed you was just building the alert manually. Here you can still leverage the AppleScript engine without using the OSA script binary on the host. And this is what that code would look like here. Another example, in my Mac Shell Python tool to navigate the file system, it did things like cd, ls, pwd, to get around on a host. An alternative would be using the Cocoa API, you can leverage the file manager class, which will allow you to do things like get your current directory path, get contents of your directory, change your directory path. And what's neat with this class also is if you're looping through items in a directory, you can check a property called hasDirectoryPath. And if hasDirectoryPath evaluates to true, that lets you know the item you're checking is a subdirectory and everything else is a file. So this is a neat way programmatically to kind of navigate the file system and enumerate files and directories. Next example, on the command line, OSA script-E, return to clipboard, gets clipboard contents. And from a code perspective, what you're essentially doing here is working with the NSPasteboard class. And from a clipboard perspective, on the back end, it's basically considered a pasteboard. So you're just getting the string contents of your pasteboard, storing it as a variable where you can send it to another host. So those are examples of getting off the command line and using code. And next, what I'll do is just kind of walk through some examples of how you can build red team focused apps or apps for red team purposes. Again, using code and not having to rely on the command line. So if you're inside of Xcode and you want to build your own app, you select a Cocoa app and you're brought here. And I'll kind of walk through some items on the left. So here's your main storyboard. This is where you design a window that when your app is executed, that the user sees and interacts with. So that's what the main storyboard is. You have on the left appdelegate.swift. That's where you can put code around terminating your app. You've got viewcontroller.swift. That's where you can put code behind your window elements. So if you want the user to click a button and something to happen, you put that code in viewcontroller.swift. And then assets.xcassets, I've used that to add images to your window or set an icon for your app package, things of that nature. So, and then here you just continue to design it until you get it to the point where it's ready for red team use and it entices a user to do something. So let's say you've got that set up. Your next step what you do is you'd have to go through sandboxing to specify what accesses your app needs. Now you could completely turn off sandboxing, but I would recommend keeping it on and just specifying what accesses your app needs. And the reason being is, and we'll talk a few more slides down the road about this, but if you turn off sandboxing, it could affect your ability to get the app notarized, which you may have to do depending on the target OS that you're building for and things of that nature. So I recommend keeping it on. And here's an example of setting your sandbox for a red team app. In this case, we have the sandbox set because in this case we have the app that's connecting to a C2 server, so we want outbound connections enabled. We want the app to be able to access the camera, contacts, calendar, and then files on the system. So that's pretty easy. You just click capabilities at the top and you check these items. And what happens is each item that you check in the sandbox, it creates an entitlements file that's part of your app package. So when your app is executed on the host, the operating system reads from the entitlements file to make a determination of what your app is allowed to do. So that's kind of how it works. So now, let's say you've got your sandboxing set up for your app. Now you want to start adding code behind the elements on your window. So like when a user clicks a button, something happens. Here, what you would do is you go back to your main storyboard and you option click. So you hold down the option button and click viewcontroller.swift. And that will bring up the window. That dark window on the right is the viewcontroller.swift code. So you've got your code next to your design window. And the reason I believe Xcode has it set up that way is so that you can easily drag and drop elements from your window over into your code. So that Xcode knows now that this variable is linked to this particular item. So in this example, in a screenshot, like holding control and dragging and dropping that text box, it created a link in the code, an IB outlet variable. And IB is just an interface binding. So that's kind of how that works there. And here's an example of code here if you want to put code behind your app window on to have it actually capture credentials. Here's an example of what that code would look like. Once the button is clicked, the string values of those two text boxes are grabbed. I use AlamoFire third-party package to allow easy URL requests. So you just grab the contents of your text boxes that you're targeting, make the URL request, set it as HTTP post, and then when you do you set up a task, and then when at the bottom where it says task.resume, that actually executes the task. Give it a second to sleep to make sure it completes the task, and then you can exit out. But something to keep in mind, depending on how you distribute the app for your red team, if you're going to plan to have it hosted where users download it through their browser or email it out as an attachment, you'll have to get your app signed and likely notarized for future versions of macOS as well because of Gatekeeper and what Gatekeeper checks for. So you have to set up your own developer account. I recommend a burner account. That way, in case it gets kicked out of the developer program, you can move on to the next one. And you can go to developer.apple.com, pay your $100 and get that set up. And here's another example of what you could do in your app code. I'm not sure if any of you guys or how many of you are familiar with AppFell by Cody Thomas. Yeah, pretty cool. It's a really cool cross-platform C2 infrastructure for framework, if you will, for Mac, which includes Mac OS. And so really cool project. So if you wanted to have your app initiate a connection to an AppFell server, you could add this code here. And I'll kind of step through briefly what's happening is you're creating an asynchronous thread, which is feeding in this code here where the script variable is. That is the JavaScript for automation command that you're feeding into OSA script, but you're feeding it into the class rather than the binary on the host. So it makes it a little harder to detect. So you execute that, give it a second, and then the set activation policy of accessory will hide your app from the dock at the bottom. And then the last line will actually hide your app itself. So the app is in the background connecting to AppFell, though to the user it looks like nothing's running, like it disappeared and is gone. One thing to keep in mind, app transport security for Apple will check connections from your app out to a server. So what I've learned is not to use self-signed certs because ATS will block those. But if you have a valid cert or even a Let's Encrypt cert is fine as well, where ATS will allow that outbound connection. One other thing about notarization, I did some testing where I had an app that had credential stealing like the previous slide and had AppFell code like what's here on this slide, and sent it up to Apple to be notarized. And what I found was that Apple successfully notarized it and sent it back. And then about a week later, they did some back-end processing, and then they revoked the certs for that app and kicked the account I use out of the developer program. So technically, I had a week to use it, which doesn't sound like a long time, but if you get someone to execute your code and it's already running, even it doesn't really matter if they've revoked the cert because I already have my shell on the, I have access to the host. So just something to keep in mind. Running short on time, so I'm going to very quickly step through these examples of detection for both old, kind of what I would call the command line based post-exploitation, as well as the code-based, which is looking at OSA script execution, what's spawning shell environments on your host, and at the end of the day, just having good network visibility, being able to detect beaconing type activity, seeing anomalies around apps. Are they dropping other files? Are apps beaconing out? Things of that nature. One other thing I'll mention, I recommend for blue teams is to stay up with Jamf, which purchased Patrick Wardle's company, and he's been on the forefront of bleeding edge research for a while. I think some cool things will come out of this joining between these two for blue teams. Last, just here's a link to the Swift version of my Python code on my GitHub, and I have a blog post as well that goes into more detail for things that I mentioned here in the talk. And definitely check out AppFail by Cody Thomas. So again, out of time, but thank you guys for listening in, and feel free to come grab me if you have any questions.
Huh? Yeah.
I should have done that mid-talk.
Yeah. Do it again for the finale.
No, like mid-talk. Yeah, mid-talk.
All right. I think we're 1 minute early, but thank you guys for coming in here, listening to this talk. This is not going to be as deep of a dive as the last one. This talk is IPv6 security considerations for when just turn it off isn't good enough. And that quote, just turn it off, is one that I've heard from a lot of people when you mention IPv6 and security. They just shrug and say, yeah, you don't have to call anybody out. You're all here because of that. I'm pretty confident most of you are here just so at the end you can say, but I'll just turn it off anyway. You know? Okay. So I got the idea for this talk from talking with a colleague of mine. I was having this big existential moment. I turned to him and I said, dude, do you think we're ready for IPv6 security? And he looked over and said, Doesn't matter, man. We'll just turn it off. And I'm like, we're not in charge. We don't have switches. We can't turn anything off. Our job is just security. So, before we go any further, a little bit about me. My name is Jason Lewis. I have a company called Route 6 Security. This is my security job. Just full disclosure, I'm also in the Air Force Reserves, and disclaimer, none of the opinions are theirs, they're all mine, so don't be affiliating me with anything. But my background is primarily in business, and I spend a lot of my time thinking about policy, which is probably way different than most of you guys in here. This conference is not policy and business, but it occurred to me when I was having this talk with my colleague before that it is the reason you can't turn stuff off, I believe, is going to come up, is that as we move forward, here's how I see things moving, is that there's so many IPv6 addresses and so few IPv4 addresses that right now some companies make extra money on the side just selling their unused IPv4 space. It's a revenue producer for some people. And IPv6, on the other hand, they're just giving away. Aaron will just give you chunks of it if you want it. And for that reason, eventually what's going to happen is it's going to be so cheap that startups are going to start using it. This is already happening some places. Startups are going to start using it. They're going to make cool applications that do cool things. And your company, whoever you work for, whatever organization you're in, is going to want to use some of this stuff. And at some point or another, they're going to run into a wall. Right now, you have some places that only do IPv4. You can't do anything with IPv6. It's going to flip at some points, and it's not going to be a killer app. It's not going to be the one thing that you have to have. It's just going to be subtle, and eventually, not being able to use these things, or if you are in an organization that produces some sort of consumer-facing product, you're going to want to be able to capitalize on that market share, right? You're going to want to be able to get to those people who are using those devices or that application that only takes IPv6, and someday somebody's going to come down and say, you know what? We're going to do this. This is our new business model. And there, look at that. You can't turn it off. Even if you physically could go to the machines, or you can click around and turn everything off, and even if you were able to track down every instance of IPv6 on your network and shut it down, your bosses would fire you. Right? So your position at that point would just be go find a new job or adapt. And so hopefully here today I'm just going to try to get you nudged in the direction towards adapting, if that's where you're at, so we can move on. So the intended audience for this is for security personnel. A lot of the IPv6 security stuff out there is how to configure your network as if you're an administrator. And again, it's great stuff to read. But if you're like me and you do a lot of blue team type of things, or you're looking through network, you're looking for bad guys on your network, you're not really concerned necessarily with how to configure your network, although you will recommend it to people. You are concerned with IPv6 special considerations and how to make that work for you. I also assume that everybody in here is passingly familiar with IPv6, that you at least recognize it as a thing. That if I showed you an address with colons in it, you'd be like, yeah, it's IPv6, move on. It's good. And finally, like I said at the beginning, I assume most of you guys in here are the turn it off folks, or at least people who are familiar with that position and think, hey, maybe I should position myself to take that guy's job whenever he finally butts heads with the business people and loses. So, oops. All right, an overview. Just to give you an idea what we're going to talk about here, I'm going to cover extension headers, logging addresses, attribution, and by attribution I mean figuring out how to associate the network traffic with a host that's producing it, not necessarily a behavior with an APT or something of that nature. We're going to talk about Slack, and if you don't know what that is, it's good. We'll get to that as well. Some toolkits that are out there, resources that you should be aware of, and a few takeaways in quotation marks. At the very end of this, you should at least be able to walk away with a couple things that in a meeting you can interject at the right point. Somebody's going to look at you and nod and say, exactly, give that man a raise, or woman. So extension headers. You guys are probably familiar with the issue of fragmentation in IPv4, right? And it's been fixed by and large in most devices on the network. Fragmentation, being able to bypass firewalls because you're able to hide what is actually inside the packet, is something that is still an issue with IPv6. So the extension headers are very, very long, potentially long chains of information that are right between the actual IPv6 header and then the underlying data. So these long chains could potentially be too big to transmit in one packet, and therefore you might need to fragment them. If that happens, then potentially you could put together, especially if you don't have if you have a stateless firewall instead of a stateful one, then some of these things could slip through and traffic could get into your network that you don't want. So what you need to be aware of is that these extension headers are new to IPv6, but they create issues similar to what you experienced with IPv4. And while the best practices and common sense say don't let that happen, we don't want to have fragmentation, sometimes it's just the way things work. And in particular, there's an issue with turning off fragmentation for network devices that are in between other devices that aren't aware that fragmentation is not allowed. If you break that chain, now you break the whole system, and that makes people unhappy. And once again, people will tell you, you gotta switch it back. So, keeping that in mind, it'd be nice if everybody could agree on one standard to implement. But IPv6 implementations of the RFCs vary widely. We get kind of accustomed to IPv4 and how everybody just does what's supposed to happen. They teach it in classes as if there's only one way to do networking, and that is what the RFCs say. Well, in IPv6, there are competing RFCs, there are deprecated RFCs, and if you have any networking device that's been built over the last 10 years, which it's not uncommon to find in many places, you could have a wide range of implementations of best practices and deprecated best practices and alternative best practices implemented there. So if you're not tracking on these things and you're not asking the questions like, what are we doing here, then you might be surprised one day to find out that people are evading your ACLs and potentially DOSing you as well whenever they send these potentially unlimited extension headers through your networking equipment. The hardware implementation can't handle it because it's too big, so it sends it up to your software, and now you're unpacking these extension headers in software and DOSing and getting DOSed. So be aware of extension headers. Another thing, I spend a lot of time digging through logs. I imagine you guys do too. Everybody digs through logs. And in IPv4, there's only one way to write an address, and you guys, that's great. It makes it easy. But in IPv4, so all three of these are one way, or one address. Now the bottom one, I don't think I've ever seen anything record an address that way. Fully written out, all the zeros, all those things. For those who aren't familiar, you can use double colons once in the middle of any of that to get rid of any number of zeros altogether, and then you can get rid of all zeros to the left within the semicolons themselves, so you can make a big address smaller, much like it is at the top up there, although I'm missing semicolons. I apologize for that. Or colons. Anyway, so you're unlikely to see the bottom example, but the top example and the middle example, where you have FE in lowercase and FE capitalized, that seems like a subtle difference. But the best practice that I've read and the one I believe in is the top one, where you use lowercase. But there are RFCs that are published, current RFCs out there that use the middle one as their examples. So even the IETF can't figure out exactly what they're doing. It seems small, but whenever you go to use grep, you're going to miss stuff. But if you're writing a script to pull stuff out of these logs, then you're going to miss things. Now, depending upon what you're using to go through your logs, it might take care of this for you, right? Splunk has a plugin that makes it all go away. But if your regex was written by somebody in your shop and it was based on the idea that everything looks like one of these, and then it's not, you could run into issues as well. You might not be logging what you need, and you certainly might be missing information. All right, and now we're going to talk about attribution. As I mentioned before, this is not attribution to an actor. This is attributing network traffic back to a machine. Classically, IPv4 addresses are pretty simple. They'll either be statically assigned or there'll be DHCP leases that are renewed on a regular basis, and it's fairly static. If you look at a week's worth of network traffic, you're going to have a good idea of who is talking to whom, and not a lot of issues there. However, with IPv6, that's more complicated. So one way to give IPv6 addresses is to just let the machines do it themselves. You can do stateless configuration, and they'll make up their own address. And that sounds dangerous, and it can be, but that is why they sometimes check it against other stuff, And they had the clever idea to use the MAC, these EUI64 extensions. What they do is they take those last 64 bits of the address, and then they use the MAC address, and to make it long enough, they shove FFFE in the center of it, and then they flip a bit in the 7th bit from the left, if you're looking at it on paper, and that is their new address. That's great, because that tells you which machine it was. If you know which computer has that MAC address in it, then you should have a good idea. And so that makes attribution fairly easy. And that also, so I want you to take away from this is that if you are lucky enough to just be using these kinds of addresses on your network, that if you see a bunch of FFEs in the middle of your addresses, you can probably reverse that back by reflipping the bit, pulling out the FFFE, and then you'll know the MAC address. And that's how you can figure out who it was, unless you also recorded the MAC address in your logs. However, that's not the best thing to do if you're using those addresses to go out over the internet to conduct business. Some people didn't like the idea that people could be tracking you by this address everywhere you go, and they wanted more privacy, so they created privacy extensions, the privacy addresses. And there's actually a couple ways to do them, but the net result is that they look fairly random. They are randomized. And these addresses provide the user with a little bit of anonymity, which is great unless you're using these addresses to try to figure out what's happening within your network. I mean, privacy addresses are great to go out to the wide world, but from a security perspective, they're annoying, much the way that IPsec can be a problem. So these privacy addresses are difficult, but one of the only ways you're going to be able to figure out these things is by keeping track of the neighbor advertisements. And if that's a new word to you, what you guys need to be aware of is that ARP is dead in IPv6. It's been replaced by neighbor advertisements and the neighbor advertisement, or the neighbor table. So what you need to be doing is recording these neighbor tables, because some of these, depending on the implementation, again, everything varies widely. Ubuntu has a 24-hour standard lifespan for a privacy address. There are other devices that go as low as 4 hours. So what this means is that even if you look at 1 day's worth of traffic, the same machine could be using multiple different addresses to be able to conduct whatever behavior it is. So if you're not keeping track of these addresses, if you're not logging them and retaining those logs long enough to meet whatever look-back responsibility you have, if your organization wants you to be able to look back 30 days, you need to make sure that you're keeping these neighbor advertisements that long. If you're in a situation where, like I sometimes find myself in, where I'm not actually able to affect how much logging is taking place, I am a guest on somebody else's network, and while I'm there, I have to do the best I can. You can also pull these off the wire, and it's a good thing to retain as well, just capturing them, because what these neighbor advertisements are, like an ARP, it's how that client, whenever the information's come back in, is able to say, I'm at this address, please go ahead and send it to me, and that's going to be your only clue, unless you're able to find it on the host itself. And then finally, I want to talk about the DUIDs, the DHCP user IDs, which are, they're interesting because you can have multiple interfaces on your computer these days, right? Like I've got wireless, I've got an Ethernet connection, I've got Bluetooth. All of these are network adapters. Each one of these has a different burn-in address, and the thing about the DHCP, so if you choose to use DHCP v6 on your network instead of this stateless auto configuration that I was just discussing, then these DHCP logs will retain this information, and they'll be able to associate this DUID back to a machine. But one thing I want you to be aware of, just a fun little tidbit for your information, you never know when you're going to need it in your back pocket, is that the DUID assigned to a machine is based only off of one of those interfaces. And it may not be the interface that was being used in order to go out. So even though the connection was wireless, it may be referencing the MAC address from the Ethernet card. When this is going to matter to you the most, I don't know. I don't know. But someday you might think back to this talk and be like, got it. That was an obscure piece of trivia he pulled straight from the RFCs. All right, so Slack. Strange things with Slack. All right, you have router advertisements. So stateless auto configuration. And most of us use the DHCP, where a host comes on and says, hey, I need an address, and the DHCP server goes back to it and is like, hey, here's your address, here's your default gateway, here's your DNS information, you have a good day in internet well. Well, if you're not using a DHCP server, then you don't get that kind of stuff. So to fix this, instead now routers just advertise themselves. They say, hey guys, they use multicast addresses and they just say, I'm a router. Anybody out there who needs a router, hit me up, like a bulletin board in a coffee shop or something like that. And just like a bulletin board in the coffee shop, you don't know what you're getting. And so some of these, it's very easy to fake a router advertisement. And there are multiple sources out there, multiple scripts that have been written to just generate these router advertisements. And what that'll do is allow you to be a man in the middle. And this man in the middle capability is, of course, one thing that security people don't like. But assuming that the router advertisement is not coming from a malicious source, it could potentially also come from just a misconfiguration. A host gets on the network and says, hey, this is my default gateway, you should try it. The other host picks it up, sets it as their default gateway, and next thing you know, no traffic's leaving your network and you can't figure out why. This is less of a security issue, but more of a problem you might run into. And then this is particularly an issue if you think you turned off IPv6 on your network, so you stopped worrying about it, and now you have the occasional rogue advertisement going around. All right, so toolkits. Some of you guys are pen testers as well. You're a little less worried about how to track logs as much as you are worried about doing stuff. And also, if you want to be able to figure out what your network's posture is, you may use some of these. The best one, if you type in IPv6 toolkits, the hacker's choice is going to show up. It's in Kali nowadays. It is robust, and it's never let me down. So there it is. I recommend it. But another one out there is the SI6 Network IPv6 Toolkit, and those guys, they do classes. I think there's one in Paris coming up here pretty soon if you guys have funding. It is also pretty decent. And then finally, SCAPI 6. It's not really a toolkit, it's just a tool. Everything that SCAPI can do, it can do too, so you should try it. Craft packets to make sure that your network is actually responding the right way. Making sure these router advertisements are not being picked up when they shouldn't be. Making sure that you don't have other issues that I've spoken about. So this is from the SI6 toolkit. I don't know if you can read that back there. It looks a lot better on my computer. But there are all sorts of things that are in this toolkit, and I chose the SI6 toolkit as my example because the hacker's choice actually has far more than I could fit on the screen. It'd be multiple slides worth. But you see here that there are things like IP address analysis and manipulation tool, a tool to perform attacks based on IPv6 error messages, router advertisement forgery. And then one I want you to look at down there is the SCAN6, which, near the bottom. It's an IPv6 scanning tool. I wanted to hit on real quick, bonus, IPv6 scanning. A lot of people think that the obscurity, that having that large address space will give you some sort of security, which we all know is a fallacy, right? Security through obscurity. So I want to let you know that there are people out there developing algorithms to make it easier to scan these large swaths, and those are getting better. But even then, sometimes your admins set your security posture up for failure by doing things like incorporating the IPv4 address that used to be into the IPv6 address. So with any knowledge of the old IPv4 scheme, ta-da, you found it. And even then, scanning the IPv6 space for a 10/8 worth of addresses is just as easy as scanning it in IPv4. Another thing is that you use a service as a suffix, so that would be an NTP server right there. And that's one, people will try that. Oh, your DNS server? Let's just try your address 53. And too often, that's exactly what it is. So if you're able to advise people against this, I recommend it. And the last one is using words in there. And there are a lot of cool words you can create with 0 through F. And finally, takeaway. If you guys are going to take anything away from this, of all the resources I use, all the resources I've read, just read this one. This is a draft RFC written by a guy named Venki, who also was a co-author of IPv6 Security from Cisco Press, he knows a lot. He's been working on this for a long time. This is about 20 pages worth of reading total, and it's like a full primer on IPv6, cuts out a lot of the baloney, and goes deeper into the security issues than I am here. So that's it, one resource. All right, so finally, the takeaways. This is it. So if you get nothing else out of this, you just want to go back and you want to sound a little bit more like you know what's going on IPv6. You want to be ready to take the position of the guy who retires because he don't want to bother with it and he just wants to turn it all off. Ask some of these questions. Like, how does our equipment handle extension headers? Oh, good question. We'll make sure we include that whenever we're purchasing equipment. You're a manager now. How are we standardizing our addresses? All right. Are we using capitals or are we using lowercase? Are we using both? Did we download the plugin for Splunk? Yes? Good. Look at me, I'm considering things. Are we maintaining neighbor discovery information long enough to meet our obligations? Will I be able to attribute activity I see on my network to an actor 12 hours from now? Are you relying on me to be able to just go back in there and most of the addresses still be the same? No? Well, we got problems. Sometimes you, depending on who you work for, you may have legal and regulatory obligations to be able to attribute things. So make sure you're keeping these neighbor discovery logs longer. All right. Does anybody have any questions? I think I have a couple minutes left. All right. Yes?
I have a question, actually. Can you go back to the tools?
Tools. Yep. Did you make one of these?
No, that's one for sure.
Okay. Yep.
Well, actually, one back, the white page.
White page. Yep. Yes?
Serious question. Have you seen a standard on how people verbally communicate IPv6 addresses?
No. Is there one?
Well, that's hard.
Yeah. The question was, is there a standard way to communicate IPv6 addresses? And I have not seen one. Yes, ma'am?
Are you familiar with CIS benchmarks?
No.
I think Wallace embraces it. Basically, it's just a policy compliance scanning tool you can use on images and environments. And they have a specific assessment that just ensures IPv6 is turned off.
Mm-hmm.
Are you suggesting that maybe not be good enough and we should look further into other
I do think that. For now, don't get me wrong, like I'm not the kind of guy who goes home and sets up an IPv6 home network just for the fun of it. I mean, like I have my side network, but my production internet, if my internet went out, my wife would be very upset, my kids too. It's just easier to go with the default IPv4. If it's easier and cheaper, just do it that way. I'm a business background guy. But I do think that one day, that there will be a business case for not doing it, and that's what's going to drive it. So yeah, right now in the military too, the STIGs, they also say turn it off. Everybody's saying turn it off, except for the people who aren't. Like Facebook and Netflix and Google and Android. So yes, it's great until it's not. And really all you're doing is avoiding technology. I do think that as security professionals, it's better for our jobs and our future to prepare ourselves for whenever that's not the case anymore. But yeah, whether to turn it off or not, it really depends on your business use case. Yep. All right. Yes, sir.
So basic question, make your comment. So Facebook has their set of servers on IPv6 really available right now on the internet?
Yes. As of 2 years ago, their adoption rate was 50%. Internally, and I've seen little exponential graphs that show more. A lot of people are working. ISPs and tech giants are going heavily towards straight IPv6. Now they're going to have to dual stack for a long time, I believe, but definitely if you want a job there, good stuff to know. And also, yeah, that's going to be what's driving a lot of this in the future.
So do we get added from V4 to V6 somewhere along our ISP chain?
I'm not sure how they're implementing it to make it work. I think if they're tunneling it is probably the way that it's happening. And yeah, can't speak more on that for them. Sir?
I think just the question around the eventual need to adopt IPv6. Do you think that eventually the need is going to go to people requiring IPv6 to work in order to use IPv6 services, or do you think we're just going to put all of the IPv4 stuff behind that?
I believe that startups will lead the way where they can't afford to do IPv4, and then eventually, so everything's going to be tunneled at first, and then somebody's going to be like, why are we tunneling all of this stuff? Every major OS supports IPv6 natively. Every major networking device supports IPv6 natively. Why are we spending the extra overhead and resources to tunnel this? And then there it is. All right, guys, well, thank you. My time is up. I appreciate you guys hanging out for the talk.